Below we explain how to program the machine. Press the navigation main menu and on the first page, we find File Management. By going up or down, page up or down to find your destination, press OK. Before creating a new file program, let's first check what the existing number is to prevent old programs from being overwritten. So press the third. The current program 000 number is already occupied, so we enter E. The next time the new program is created is R. We look at the program number mainly to prevent overwriting the old program when creating a new one. Then press Cancel and we create a new program. Then select E to open the new program. This file number is the number you just viewed, so enter E next. Here, just press E. Press OK. Then we enter the product name. Let's check the product name or look at the name on the PCB. There's a name here, let's take a look. You see this is writing a P4. This is 128×256. The product naming method is based on the requirements of your company. Next ask how to switch or how to enter different characters. We check what state the input method is in now, and then press the key to switch between different characters. Press key to switch. View input method changes. We switch to alphabetical input. There are multiple letters and numbers in one button. We press the button multiple times to switch quickly. In a keystroke, make multiple quick presses to switch between different characters. Let us demonstrate it and see the changes. OK, let's enter the P4 character next. Press the key to switch to numeric input mode. The next naming method is up to you. Every company is named differently. If the name needs to enter characters, press to switch to letters and enter. Then press E to enter. The character can only be entered when it is switched to English. Next we switch to numbers and enter other characters. After completing the input, press OK. We will not introduce these default parameters. Other video teaching materials are introduced. Find the corresponding video learning. We have set these parameters OK before leaving the factory, and we do not need to modify them under normal circumstances. When we are making the program, the height of the Z-axis must be higher than the height of the aluminum block to prevent collisions. The working head is raised upwards and higher than the other sides. We modify the height of the default parameter to prevent collision. First change it to 30 毫米. Delete the original value 15. Change to 30, press OK. OK. Why doesn't the other number 15 need to be changed? Because that parameter is for adsorption type screw pickup. Next, we move the working head according to the X and Y axis. Use your camera to find screw holes. The display now appears blurry and out of focus. We need to adjust the focus of the camera. Rotate the camera's focus to adjust. We can debug and view at the same time. OK. Next, we find the screw hole location. You can use a reference object to find the screw hole location. Select different speeds to switch the moving speed, and move to the center of the screw hole. We set the speed or distance the working head moves every time it is pressed. Press main menu to navigate pages. Select speed or acceleration option. OK. Select number key, manual speed. OK. By modifying these parameters, each time you press it, you will move the distance. If each movement distance is too large, modify the movement distance by lowering the parameters. Enter 60 and 30. Fast, medium, slow, 3 speeds to modify. OK. Then keep pressing cancel to return. Move to the center of the screw hole. Then press the E key to record the coordinate data. You see, the current coordinates have been recorded. Then switch the movement speed to medium speed and find the next screw hole. Suppose you want to modify the previous coordinates or view the previous coordinate position. Use the direction keys to move to the corresponding coordinates. Then press to move to the coordinate position of the cursor. This way you can check whether the coordinates are in the center. Press this key to move. Then press down and move the cursor to the line below. Find other screw holes. Find the target screw hole position, press the E key, and record the current coordinate value. The other screw hole coordinates are also operated in the same way. Press E to record coordinates. If the coordinate is not at the center hole of the screw, move the cursor to the coordinate and press E to modify it. How to uniformly modify the Z-axis height of coordinates? Press the machine button and the screw feeder will blow out a screw. After pressing the button, a screw comes out. Then move the X, Y, Z coordinates and insert the screw into the screw hole. Insert the protruding part of the screw into the screw hole. Just before the screw is inserted into the screw hole, reduce the Z-axis movement speed to slow. Switch the speed and check if the screen is slow. Then slowly lower the Z-axis to insert the screw into the screw hole. There are two conditions. First, the protruding part of the screw must be inserted into the screw hole. Second, when the screw working head is opened, it will not touch the lamp beads next to it. Like this, when the screw working head is opened, it will not hit the LED. Open the screw working head manually and check whether it hits the LED. OK. When the two conditions are met, the current height is the coordinate of the Z-axis. Remember this height. Then press this key to batch the Z-axis. Enter the first screw hole serial number as the starting address and enter the last screw hole serial number as the ending address. Then enter the height of the Z-axis coordinate. In this way, all Z-axis coordinates are modified. Z-axis batch modification. Then press reset. Next, check the speed, torque and other parameters of the two motors. Select the motor working head, number E is on the left and number R is on the right. Set the target torque to 30. Number of rotations normally set to 99. If slippage occurs, the screw is too deep or too shallow, modify the number of rotations. Every time the machine assembles the screws, the torque and number of rotations will be modified in real time. According to the different modules, heights and materials of each product, make corresponding modifications. For all parameters in this interface, we only modify the torque, number of rotations and speed, and do not modify other parameters. After completing the procedure, when assembling the screws, check and then modify these parameters according to the situation. According to the previous situation, we only modify the torque and number of turns. Of these two parameters, one is torque and the other is the number of rotations. If any value reaches the target value first, the machine will stop. Assuming that the depth of the screw does not reach the target point, we can modify the torque or the number of rotations. we can increase the torque. If it exceeds the target point, we can reduce the amount of torque. When we assemble the LED module mask screws, they may not be modified by torque, so we assemble them by modifying the number of turns. Or assemble screws in depth mode. The side sensor controls the depth of the screws. We usually use this depth mode when assembling small screw mod masks. This is switching between Chinese and English interface. The number of rotations and torque of the motor and the results will be displayed in real time. The login password is ba. If we need to modify parameters, first select the target motor and then modify the parameters in the task. This is motor no E. This is motor no R. The general introduction to screw machine program production is now complete. Don't worry about working heads 3 and 4. No need.